This tutorial discusses solubility. Solubility is the maximum amount of a solute that dissolves in a specific amount of solvent. So just how much of that substance you can get into the solvent. And it is temperature dependent. So as the temperature changes, the solubility will change. It's typically expressed in grams of the solute per 100 grams of water. And they refer to it with water just simply because it's the most common solvent. So if we're looking at something that's unsaturated, that means it can actually dissolve more. There's more room for those solutes to go in there. You can actually physically see it because nothing settles on the bottom. It's all in solution, and you could actually put more in if you wanted to. A saturated solution, however, you're going to start seeing particles on the bottom because basically it's absorbed as much as it possibly can, so it ends up sitting on the bottom afterwards. So it contains the maximum amount of the solute that it can be dissolved. Anything undissolved is on the bottom of the container. So it contains particles that are actually already dissolved in the saturated solution, and it also contains particles that are in the process of being dissolved. So this is actually doing it over and over again. Molecules are coming together and then breaking back up again. And that's called equilibrium. So label each of the following solutions as saturated or unsaturated. If it disappears in water, when you put it in the water, that means that it is an unsaturated solution because it means you could actually put more in there. Sugar is added to a cup of water, does not disappear, sits at the bottom. That means it is a saturated solution. Alright, so let's do some mathematical type equations. And it's really not as much math as it is in a comparison. So at 40 degrees, KBr solubility is 40 grams of KBr per 100 grams of water. If there's only 60 grams in there, it's still not that maximum, so it's still considered unsaturated. Here, they've changed it from 100 grams to 200 grams of water. You're still looking for a ratio though. So if we divide both of these by 2 to make it that 100 grams, that's 100 grams of KBr for 100 grams of water. That's over that 80 gram max. So therefore, that's a saturated solution. 25 grams of KBr to 50 grams of water. This time we're going to multiply by 2 to get to that 100. That equals 50 grams of KBr, which is below that 80 gram max. So therefore, that's unsaturated. As I said earlier, the solubility is dependent on the temperature. So the warmer it is, the more that's going to be dissolved. This is specifically for solids. The hotter it is, the more the solids will dissolve. However, this is exactly opposite for gases. If you have a gas in here, for instance, soda pop with CO2, carbon dioxide. If it's a warmer temperature, those gas molecules are going to want to escape. And that's due to Henry's law, or Henry's law actually explains it. When you hear that noise, when you open up that can, that's the pressure being released. With more temperature, there's more gas pressure. The gas particles are trying to escape. And so, therefore, once that pressure is released, those gas molecules escape. And so you actually end up dissolving less. So, if you have a bottle of carbonated drink, could possibly burst when it's left out in the hot sun. That's because those gas molecules are moving faster and faster and faster and trying to escape. And then it's going to try to break through that pressure and open up the container to release the pressure. Why do fish die in the water if it's too warm? It's because that oxygen in the water is actually escaping when it's hotter because those molecules are moving faster. And it's escaping, so there's not as much air in the water for the fish to breathe. So therefore, the fish are essentially suffocating. But not all ionic compounds are soluble. So we're going back to the solids. When it comes to lithium, sodium, potassium, ammonium, nitrate, acetate, those are all soluble 100% of the time. But it gets questionable when you have Cl minus, Br minus, or A minus, dependent on what it's bonded to. Same as sulfate. So for instance, if you are having an upper GI, you might have to drink some solution with barium sulfate. If we look here, here's sulfate. It's typically soluble unless it contains barium. That makes it an insoluble salt. So if we look at these individually, K2S, this one is soluble because it contains K. CaNO3, well here's NO3, it's always soluble, and that's the reason why. PbCl2, well here's Cl, it's bonded to the Pb, so that's going to be an insoluble chloride. So you're basically going to go look at these compounds and double check it with the list. Here's another one, so cadmium sulfide. Insoluble if it's S2 minus. So we have sulfur here, and we have sulfur here. Lead iodide. Iodide is typically soluble until it's mixed with lead. Lead hydroxide. Hydroxide are always insoluble. So you're just going to have to match up the compounds with this cheat sheet. And that's how you determine the solubility.